reaching to subtopic 5.3 that talks about forces in 2 dimensions. Question 1 asks about a force that produces equilibrium. We agreed word equilibrium means when forces are equal but opposite, so they cancel each other out. So we call these forces as equilibrant. Here, which one of these can show that the object is in equilibrium? Of course, going to part A, these two are not equal. The upward force and downward force, they're not equal, so this is not correct. Option C, these also two forces are not equal, so they don't cancel each other out, while B, the upward force and the downward force are equal and opposite, they cancel each other out, so this is the scenario of equilibrium, so B. Here, in case of inclined surface, inclined which is not straight horizontal, it is inclined with an angle with the surface. It has an angle, specific angle with the surface. So here we have 100 Newton box is resting on the plane inclined at 40 degrees above the horizontal as it's shown here. So we need to find the components of the weight, the parallel and the perpendicular component. Now, our weight is Fg, so it has parallel component and perpendicular component. Which component is considered as the parallel? The parallel component is the Fgx, as we can see here. So, Fgx is considered as the parallel component, while the perpendicular component is Fgy, which is this. For the parallel component, what formula can be used to calculate it is Fg sine theta, while for the perpendicular component, the formula is Fg cosine theta. So the cases in the calculation, the x component and y components will be different based on the surface, whether the surface is horizontal or inclined. Let me explain it here. So, if the surface is horizontal, such as in this case, this is a horizontal surface, and we have, this is the box on a horizontal surface. In case of, let's consider we have a tension force here, and we need to find the x and y components, so this will be, this is the x component and this is the y component. The x component will be calculated as Ft cosine theta, and y component is Ft sine theta. But in case of having inclined surface, this is our horizontal surface and this is the inclined surface, has an angle of, let's consider 40, and we have an object here. This object has a weight which is downward, has x component, this is the weight, this is has x and y component, x and y component. Now in this case, the parallel component which is fgx will be calculated using sine. So it's fg sine theta. The x component here is calculated by using cosine. In case of inclined, the x component is calculated by using sine because this is the parallel component, while the perpendicular component, the perpendicular component will be fgy will be calculated by using cosine. So it will be fg cosine theta. So here the x component with sine, the y component with cosine. While if the surface is horizontal, the x component with cosine, the y component with sine. So going to the question here, applying the concept. If we need to calculate a parallel component, which is x, so fg is 100 sine 40, it gives 100 sine 40, it gives 64.27 Newton, while the perpendicular component is fg cosine theta, so 100 cosine 40, 100 cosine 40, it gives 76.6, yani almost 77 Newton. So the correct option, as we can see here, for the x component, 64, for the y component 77. Next question, same idea. What is the component of the weight that is parallel to the inclined plane? Which one is perpendicular? So we agreed, in case of parallel, we use fgx, which is fg sine theta. We don't have fg, but instead we have the mass. Easy to calculate by using the mass. fg is m times g, it's the weight. So 227 times 10 or 9.81, it's the same, times 9.81 or 10, so it gives 227 times 9.81, so 2226.87. This is the weight will be used here. So 2226.87 sine, our theta is 30. So sine 30, it gives 1113.4 Newton. We don't have this number accurately, but the closest answer is going to C. This is the closest. Okay, while for the perpendicular is fgy, which is fg cosine theta. Same fg, 2226.87 times cosine 30, which is 2226 times cosine 30, it gives 192. It's 1928.5. So this is the closest answer. Regarding to this point, let's go to find what are the correct answers here. Regarding to force A, it shows the component of weight that is parallel to the box, to the incline surface. B shows the weight of the box. C shows the normal force, and D is the friction force.